Hi guys, this is Terry here. I only just got the paper, right? And I'm just gonna do a quick run through of the solutions to the May 2025, right, exam. The first question here, using a calculator or otherwise, we wanna evaluate each of the following, giving your answers in exact form, right? So once they tell us use a calculator, otherwise you can go ahead and use your calculator if you want. So in this case, 3 over 2 squared is actually 9 over 4 minus 1 plus 6, right? So in this case, and if you notice, CSEC only gave them 1 mark for this. So 9 over 4 minus 1 plus 6, right? And we're going to get 7 1/4 or 29 over 4, right? So we can put 29 over 4, or you could have put 7 1/4, right? For the next one here, we have 2.1 multiplied by 10 over 7 plus 12, right, divided by 1 and 3/5, right? So this can be done directly on the calculator if you need to, right? Or you can use your order of operations in order to work this out, right? So that is 2.1. So 2.1 multiplied by 10 over 7, close brackets, right, plus 12 divided by 1 and 3/5, right? And I'm getting 10.5 for this one here, right? So you can put 10.5, or if you wanted to put it as 21 over 2, that's also a possibility, right? So that's the first two parts here, right? The next part, part B, right? I haven't really looked at the paper, so. All right, Miranda earns $8,316 per month. She spends 4/7 of her earnings on utility bills, food, and personal items, and saves the remainder, right? What percentage of her monthly salary does she save, right? So the thing is, she spends, so the 4 over 7, right, is actually, right, that's her utilities, right, food, right, and personal items, right? That's what 4/7 is. All right, and she saves the remainder, right? So she is, so 4/7, right, is spent on these things here. That means that 3 over 7, right, that's the remainder, right, is what she saves. So this here is the remainder, right? And they want us to see what percentage of her monthly salaries does she save, right? All we need to do, that 3 over 7, we just need to multiply that by 100, and that'll give us our percentage. So that's going to be 3 over 7 multiplied by 100, and you're going to get 42, right? 42.9%, right? So this here is a percentage that is being saved, right? What else they want here now? All right, part 2. They said the proportion of our earnings, right, spent on utility bills and food and personal items is divided in a ratio 5 to 3 to 4, respectively. Calculate the amount of money she spends on personal items, right? Now, let's see what's happening here. So this is the amount that she earns per month, right? But she's spending 4/7, right, on these things here. So the first thing we need to do is to figure out how much money she spent on that. So that's going to be 4 over 7 multiplied by this figure here, which is 8,316. So this is 8,316, right? So that'll give us the amount of money that she actually spends on those items. So 4 over 7 multiplied by 8,316. So this is going to be 4,752, right? So that's the money she's spending on that. But the ratio is 5 to 3 to 4. So what we need to do, we need to find how many parts do we have here, right? So that's 5 and 3, 8 and 4. That's 12 equal parts when we are talking about a ratio here, right? So you want to figure out the amount spent on personal items. So personal items is the third item on this ratio. So that is actually 4 over 12, right? Multiplied by this 4,752, right? So in this case here, That's going to be, that's 1/3 multiplied by 4752, right? So this is the amount that is spent on personal items, 1584, right? What else we have here now? So that's 2 marks for that, right? The next part, Miranda saves the same amount of money each month. Show that her annual savings from her earnings is this. So the amount that she saved per month, right, would have been, did we work that out? All right, so the amount that she spent per month, saved per month, would have been 3/7 multiplied by the total amount, which is 8316. So this is 8316, right? And that's going to give us, right, 3564. So that's how much she's saving per month, right? But we're working out what is her annual savings. So all we need to do is to take 12 and multiply by that figure, and hopefully we get the answer that we're looking for, right? So that's 12 multiplied by this, right? And we get in 42,768, right? Which is what it asks us to prove here, right? So far this question is pretty easy, right? And the last part here in question 1, we want to work out, all right? So those of you who attended my crash course would realize that we did questions like this in the crash course, right? So this question should have been a breeze, and CSEC gave you the total, they gave you the formula for the compound interest, right? So she invests this amount in her credit union, which pays an interest of 5% per annum. What is the total interest after 2 years? Now this here gives us the total amount in the account. Now here this, this question here is 1 plus r over 100 to the power n. That's the formula to calculate the amount, right? The final amount in your investment, right, at the end of that period. So this here is going to be 42768, right? 1 plus, the rate in this case is 5% over 100, right? And this is for 2 years, right? So in this case here we have 42768, right? Plus 5 over 100 is 0.05. So this is 1.05, and you're raising this to the power 2, right? So again, so this is going to be 1.05 squared multiplied by 42768, and you're going to get this figure here, right? Now this figure here is 47151.72. Now here's the thing, right? The question says, what is the total interest, right? Now that figure that we got there, right? That figure that we just got there, that's the total amount in investment. Your interest is actually your principal minus, right, the amount, sorry, that's not. The interest is the amount minus the principal. That's how you get the interest. So in this case here, we're going to take the 42,000. So that's 42768, right? Oh, sorry, I'm writing it wrong. Hold on. The amount in investment is 47151.72, and you're subtracting the principal, which was 42768, right? In this case, it's going to be minus 42768, and you're going to get an interest, right? So this is the interest that is actually paid. So it's 4,383.72. I can see some students just putting this as the answer here, but the question asks us for the interest earned after 2 years, right? That's what the question is asking for. So that's number 1, right? Question 2 is your algebra question, right? So this is question 2 here. Right, this part a little blurry, but we can still work it out. All right, so we have 2 factorizing to complete here, right? So the first one we have xy squared. So we have xy squared minus x squared y. In this case here, you want to factorize, so we're going to use the HCF method. So if we look at the x's, right, this here will be the HCF of x and x squared. When we look at the y's, y is going to be the HCF as well. So therefore, if you want to get back xy squared, this should be y, and then this here should be x, right? So that's the answer for the first part. The second part now, we have 3x squared plus x minus 10, right? So I'm just going to factorize this using trial and error, right? So in this case here, this could be 3x, this is x, right? Let's try 5 and 2. Let's try that first, right? So 3x by x, we get 3x squared. 5 by 2, we can get 10. But how do we get plus x in the middle, right? If we take plus 6 and we minus, will that work? Let's see. 3 2s are 6 minus 1, right? Minus 5 by 2. Yeah. So that is what we're going to get when we factorize 3x squared plus x minus 10, right? Again, those of you who came to my crash course would have seen we did a question similar to this in class, right? Involving indices here, right? So we have, right? I don't know if I've seen this properly here, but it looks like 4 to the n divided by 4 cubed, right, is equal to 1 over 4, right? Now on the left hand side here, you're dividing, so we can see that 4 to the power n minus 3 is equal to a quarter, or a quarter can be written as n to the 4 to the minus 1, sorry, right? Now since you have the same base on both sides, you have 4 here, we can write this as n minus 3 is equal to minus 1, and therefore n is equal to minus 1 plus 3, so therefore n is equal to 2, right? Right, let's see what's happening here again now. Part C, right? So you guys kind of come out a little easy here because this algebra question looks pretty straightforward, right? I'm not seeing anything complicated in this one as yet, right? What do we have here? So we have the lengths of 3 sides of a trapezium as shown on the diagram. The area of the trapezium is 750 square units. Write down an expression in terms of P and Q for the area of the trapezium. Now the thing is, for the area of a trapezium, that is given by a half multiplied by the sum of the parallel sides multiplied by the height of the trapezium. So they want you to write down an expression for the area, right? So area is equal to, it'll be a half the sum of the parallel sides. Now the sides they're talking about here will be this side and this side. So this will be 4p plus 3q, right? And you're multiplying that by 6p, right? That's your expression for the area of the trapezium, right? Now they told you the area is 750, so you can probably leave your answer like this, or you might put the 750 here as well, right? Either one is acceptable, right? They just want an expression for the area. I assume they're gonna ask us to find P and Q now, right? Okay, so this algebra question, guys, you all got a very, very easy question here, right? This is the only question that I was concerned about for students, right? But this question was pretty straightforward here, though. All right, so they said, given that Q is equal to 2P, right? Find the value of P. So let's write down the area. So the area is a half multiplied by 4P, right? Plus 3Q, right? Multiplied by 6P, right? And that area was equal to 750, right? Now the thing is, they're telling me that Q is equal to 2P. So therefore, anywhere we see Q, we're gonna put 2P, right? So this is gonna be a half, right? This will be 4P plus 3Q. So this is gonna be 3 multiplied by 2P, right? Multiplied by 6P is equal to 750, right? This might be the hardest part of the whole question, really. So in the brackets here, this will be a half multiplied by 4P plus 3 by 2P will give you 6P multiplied by 6P, right, is equal to 750, right? Now let's go step by step here. So this is going to be a half multiplied by 6P plus 4P plus 6P, that's 10P, right, multiplied by 6p is equal to 750, right? On the left-hand side, this is going to be a half of 10 is 5. So that's 5p by 6p. That's tp squared is equal to 750, right? So therefore, p squared is equal to 750 over 30, right? So p squared is equal to, so 750 divided by 30, you're going to get 25. So therefore, p is equal to square root of 25, and you're going to get 5, right? So that's it. That's the answer there, right? So this question 2 was not difficult at all. It could have been worse, right? Could have been worse. The third question here is construction, right? And let's see something here. So this construction question here is very similar to a question that I did in my crash course, right? So let's see. Let's get a blank page here and let's show you how to do this thing properly, right? Right, so first things first, right? So we want to draw, using a pair compass, right? Construct triangle PQR, where PQ. So again, this looks exactly like a question that I did with my crash course, right? So this is P here, this is Q. I normally tell students do a sketch first. So this is 9 cm, right? Angle QPR is 60. So this angle here is 60 degrees, right? And QPR, so this is R. And PR is 12, right? PR is 12 here, right? So this is a pretty simple triangle that they had to construct here. So first things first, we need to get a ruler, right? That's one. We also need right? We need a protractor. So the first things first, I'm gonna measure a length of 9 cm. So we get our protractor. Well, actually, wait, hold on. Let's draw a line first of all. Right, that's step one. Draw a line longer than our 9 cm, right? So the first thing I'm going to do, I'm going to open my compass so that it is 9 cm long, right? So we put this along the ruler here, that's 9. So the next thing we're going to do now, we're going to go to one end here, right? And we're going to create an arc, right? Come on this side as well. Now if you don't do this piece, that's fine, right? Create an arc here, right? So basically what we do have, we have this line here, which is P, this here is Q, and we need to construct a 60-degree angle, right? So for the 60 degree angle, right, what you could do, so you place the pointy part at the point P here, right? Now you don't need to open it this far, right? So maybe about here, so, right? Or even shorter, it doesn't matter, right? So we're gonna draw an arc, right? So you create this arc here. We're going to take this, we're going to come across to this side here, right? And then we're going to make a, right? So what do we do with that now? We're going to take our ruler, right, at this stage, and we're going to draw a line passing through, right, that intersection of the two arcs, right? So we do this here now. Next thing we're going to do now, right? So what I've done here, I've actually constructed my 60-degree angle already. Right, this here is already 60 degrees. So we need to make sure that is 12 cm in length, right? So in this case here, right, I hope I could get 12 cm. Yeah, man, I'll get 12 cm. Right, so what you do, you open your compass so that you can get a length of 12 cm. Alright, so you place the compass against your ruler and you measure until 12. So that's 12 cm here. So we're going to come at this pointy part here. And what we're going to do, we're going to draw an arc here, right? Now I didn't draw this line long enough. So there's a very small intersection, right? And all I need to do to complete this thing now here is to draw a line from here to here, right? So that's it. So this was a very simple construction that you guys got here, right? So that's it. We're just going to label that point there as R, and that's it. That's our triangle that they wanted, right? see what else we have. Right, so 3 marks for that, and then what they have here now. So they have Alright, so we have a diagram here. It shows two quadrilaterals, R and S, right? S is the image of R, right, under transformation, right? S is the image of R under transformation, right? They said describe now here it is, when it comes to a question like this here, they said describe, notice they're giving you 3 marks for this, right? So when I did my crash course, I spoke specifically about what is required for certain transformations, right? So if you look at R and S, so which one is mapped onto who? So they said S, right? Now you got to be careful with this one here because they said S is the image of R. Okay, so S is the image of R, right? So S is actually larger than R, so therefore we can tell it's an enlargement. We know that much, right? So it's an enlargement. Just by looking at it, you know it's an enlargement, right? Now your enlargement, you must state the scale factor. So the scale factor, so your scale factor key, right, is equal to what? All you need to do is to compare 2 equivalent sides. So if you look at this here, this is 1 unit, and across here, that is 2 units. So therefore, we can clearly see that the scale factor is 2. And the only thing we're missing now is the center of enlargement, right? So center of enlargement. So you notice they're giving you 3 marks for this. Those are the 3 things they want, right? Right, so we need to get the center of enlargement. So I would have shown in class how to do something like that. All we need to do, we need to draw some projection lines here, right? So if I were you, I would draw a line, right? Now let me just make this a little thicker. Right, so that is 1 line. Now this copy of this paper here, it's a little the graph paper is a little warped, right? So I might get an answer that might be slightly off, but let's see what we can get, right? So you need to draw multiple construction lines in order to make sure that they all intersect at the same point. So if I use this point here, right, so kind of looking, so I'm going to use more than 1 just to make sure we have the correct thing, right? Probably let's use this top part here. Right, so they kind of all seem to be intersecting around the same point. Like I said, the graph paper is a little blurred, so it seems like they're intersecting at that point, and that point corresponds to 3,7. Right, I'm getting 3,7 as my center of enlargement here. Right, so let's make sure we have this correct. So S is the image, right? So S is the image of R, right? So R is the object and S is the image. So because it's larger, it's an enlargement, and the scale factor is 2, right? The next part they said, right, so this next part here, we have on the grid, draw the image of quadrilateral R after this translation. So we take in R, so where is R now? So R is this guy here, right? And the vector, the translation vector in this case is given by -4, 5, right? So -4 and 5, right? So the number on top here tells you the movement in the X direction, and this number tells you the movement in the Y direction, right? So we're dealing with R. So if you're going -4, so you start with any point that you want. If you want to start with this point and you're going -4, you're going 1, 2, 3, 4, right? -4, and then you're going 5 up. So we go 1, 2, 3, 4, 5. So therefore, this here is where that point is going to be located. So from that, I can use that to construct the image after that translation. So the base is 3 units in length. So this is 1, 2, 3 till about here, I guess, yeah. Then we're going to go up 1 unit up, right? This line is going up by 1, 2, 3 units as well. So 1, 2, right? And then we're just going to draw a line from here to here, right? So that's the image after the translation, right? So it's -4 and 5. So you're going to go 5 to the left, sorry, and -4 to the left, right? And then you're going to go 4 upwards, right? So that's the image. The next part here for 2 marks, on the grid, draw the image of the quadrilateral when it is rotated 180 degrees about the origin, right? And name the image M, all right? So this one here, right, may be a little trickier. So how do I do this? Let's now. Maybe I can copy. All right, so let's see if you all seeing the screen here. So let's see how I can show you this now, right? So you want to construct, right? Or you want to determine, just now, what is the question? All right, so on the grid, you want to draw the image of the quadrilateral R, right? Image of the quadrilateral R, right? When it is rotated 180 degrees about the origin, right? So let's go to the diagram itself. So this is your center of rotation. Here is the center of rotation, right? And you're rotating R, so the rotation is how much? 180 degrees. All right, so 180 degrees, right? So it doesn't matter if I go clockwise or anti-clockwise. Basically, we're going to rotate this thing 180 degrees, right? So you can either go this way, right? Or you can go in the other direction. It doesn't really matter, right? So what I'm going to do here, right? So let's start. If I draw a line from here to here, right, and I rotate this point by 180, this point is going to become this point here, -1, right, -1, right? If I were to rotate this point here, now what you can do, right, or what you could have done, you could have used your compass here to help you with this, right? So let's see, right? Let's say I wanted to rotate, so let me draw some lines here, right? This will help us, right? So if you want to rotate, let's say that point about the origin, right? What you will do is open this, right? And then what we're going to do, we're going to make a rotation here, right? This now. Right? Because we need to figure out the exact location of that point here, right? So let's do a rotation here, right? This is going to tell us where I'm going to locate that point, right? Now you want to get 180 degrees, right? So therefore, all I need to do in order to do that, let's draw a line from here to here. All right, just trying to. Now the graph a little warped. That's the problem here, right? That's the challenge, right? Now technically, right? Let me draw this arc here. Hold on. All right, I'm just gonna draw a line here. Right, that's for the first point. For the second point, right, he's going to be on the same line as well, right? So I'll use those points there in order to locate where this image is going to be, right? So let's start back with this, right? So let's start with this first point up here. All right, I need to open. Right. So let's draw an arc from here, right? So we're going to locate this point here. So if I'm going to locate this point here, right? This here, right, is where this, you know what, guys? I feel I need to label these points here, right? Because the only way this is going to make sense is if I label the points. Let's call this A, let's call this B, let's call this C, and let's call this D here, right? Now that point B, right, this here is going to be one of the points here. So this point here is going to be B prime after the rotation, right? In the case of A, right, let's figure out where A is, right? Or actually I can figure out where D is, right? D is going to be, obviously D is going to be on this line here, right? This is where D is going to be, right? So this is D prime, right? Now let's figure out where A is going to be now. Okay, I won't be able to get that one. My compass can't go that far. All right, let's do it with C then. Right, so let's rotate this here, right? So this is where C is going to be, right? So C is going to be approximately here, right? C is going to be around here, right? Around here, right? So that's C prime, right? So the only point A, right? A is going to be around here, I guess, just now. I'm having some trouble seeing here, guys. Hold on. Okay, right. I kind of have an idea what's going on here. So this here, right, is going to be one length, right? This point A here is going to be here. This is where A is going to be, right? This here, all right. So this is what it's going to look like, right? This is what it's going to look like. This is the image here, right? If I had a cleaner diagram here, right, I could have drawn it a little better. But that's the image here after that rotation, right? I hope that kind of makes sense, right? I hope that kind of makes sense, right? So that's the third question, right? The fourth question here, right? They give them a straight line. Right, so this is the fourth question here, right? They give them a graph, right? They give them a graph with, yeah, they give them a graph and it has a straight line PQ, right? What they want here now? They want you to find the gradient of PQ and they want the equation of the line, right? So let's, hold on. Let's start with the first part, right? So they want the gradient of PQ, right? Now to work out the gradient of PQ, right, we need to first write down the coordinates of P. So P in this case is -2 and -3. So that's P. In the case of Q, Q is 3, 7. Right? Now you want to find gradient. The first thing you should do is to label those points, right? So we can label this as x1, y1, x2, y2, right? And we're going to use our gradient formula in order to work this out, right? So in this case here, all right, our gradient m is given by this formula, y2 minus y1 all over x2 minus x1, right? So 7 minus -3, right, all over 3 minus -2. So 7 minus -3 is the same as saying 7 plus 3, so that's 10, over 3 minus -2 is 3 plus 2, so that's 5, so that's going to be 2, right? So that's the gradient. That's the first part they want, right? And they're probably only giving you 1 mark for that. Yeah, 1 mark for that. And the next part, they want you to write down, right? They didn't tell us to even calculate. They said write down the equation of that line. So if we want to write down the equation of this line here, of the form y equal mx plus c, you know what the gradient is. The gradient is 2, so it's 2x plus, you can get c directly from the graph. This is where c is here. C is where you cut the y-axis, so that's 1. So this is going to be 2x plus 1. That's it, right? Nothing complicated here. Part B now, we have functions, right? So this here is going to be, right? So this is looking like a kind of easy function question. So we have two functions, f and g, right? F and g. And we want to work out, first of all, g of minus 6, right? So if g of x is equal to 3x plus 2, and we want to work out g of minus 6, basically we're going to plug minus 6 into that formula here. So that's 3 by minus 6 plus 2. So 3 by minus 6 is minus 18 plus 2, and that's going to give us minus 16, right? So that's part 1, right? What else we have to work out here now? They want you to work out the inverse of g of x, right? Well, I did so many questions like this over the past few days, right? So you want the inverse of that function, right? That's a 3-step process. So the first thing, we're going to let y equal to 3x plus 2, right? That's step 1. The next step is to interchange x and y. So anywhere we see y, we put x. Anywhere we see x, we put y. Right? And then the final step is to make y the subject of the formula. So what you can do, you can put 3y plus 2 is equal to x. Therefore, 3y is equal to x minus 2. And therefore, y is equal to x minus 2 over 3. Right? So therefore, the inverse function, right, of g, right, is simply going to be x minus, hold on, I have something written wrong here. This is 2. Yeah, this is 2, so it's going to be x minus 2 all over 3, right? So that's the inverse function here, right? Pretty straightforward, nothing too complicated there as yet, right? Then for the next part, we have a composite function, right? So they want you to show that fg of x. So let me get back the functions actually. Hold on. Alright, so these are the two functions here that they gave us, right? And we want to work out, there's a composite function, but we have to show that is equal to that, right? That is not looking too complicated, right? So if you want f g of x, right, it's a composite function. So basically, we're going to take g of x and you're going to plug that into f. So all of this, right, you have to take all of that and you're going to put that as x into the function f. So in this case, it is going to be x squared. So this is going to be 3x, right, plus 2 squared, right, minus 1, right? Now, some students may have had a little challenge with this one here now. So what we're going to do, we're going to expand. So you have to take 3x plus 2 and you're multiplying that by 3x plus 2 minus 1, right? So whenever you expand in a bracket here, you have to be careful. So you have to do it in a systematic way. So you take the first term, multiply by the first term here. You take this first term, multiply by this. We take this by this, right? This by this. And then we're going to simplify, right? So we put the arrows in place so we know what we need to multiply. So 3x by 3x will give me 9x squared. We have plus 6x, right? Plus we have another 6x, right? Plus we have 4, right? Minus 1, right? So now let's see what's happening here now. So this is going to work out to 9x squared plus 12x, right, plus 3, right? So all we can do here, right, you can decide to factor out the 3. So if I factor out 3 here, this is going to be 3x squared plus 4x plus 1, right? And then the next step now is to try to factorize that quadratic inside it, right? So this here is going to be, let's put a 3x here, let's put an x here, put a 1 here, a 1 here. So if you want to get 4x, we just need to put plus, plus, and you realize that's it. That's the answer right here, right? And they said hence solve, right? So we want to solve. Okay, so this part here for 1 mark could have been problematic for some people, right? I could see this one giving a little trouble here. Now you want to solve this, right? Basically what we have here, we have x, right? This is FG of x. X by 3x plus 1 multiplied by x plus 1 is equal to 0. Those of you doing add maths will find this easy. So there are basically 3 solutions. So you're going to put the first x equal to 0. That's one solution, right? Then we're going to put the second bracket equal to 0. So that's going to be 3x plus 1 is equal to 0. So 3x is equal to negative 1, right? And x is equal to negative 1/3. So that's our next solution. Then we have to put the other bracket equal to 0. So we're going to put x plus 1 is equal to 0. And therefore x is equal to minus 1. Right? So this question, this part here, this one could have been a little problematic for some people. Right? This one could have been problematic. Right? All right, question 5 now. Right? Question 5, we have, what is this about now? 1 mark to complete a cumulative frequency table. Okay. All right, so we have 30 students took a maths test, right? The marks they scored are shown in the table below, right? So we have tally, we have frequency, we have cumulative frequency. We want to complete the cumulative frequency table here. So first frequency, you had 3, so the cumulative frequency is going to be 3. Then we go to the next score, we have a frequency of 4, so 4 plus 3, so we add in this way, right? So 3 plus 4, you get 7. So if we want to get the next in the table here, that's 7 plus 8, that's going to be 15, right? That's what's missing here. And if you want to get the next one, this will be 19 plus 6, right? Which is going to be 25, right? So for 1 mark to complete that, do they want us to do anything? Okay, I guess not. Right? So they didn't ask us to draw a curve at least, right? All they want, let's see what they want here in the table. So they said use the information in the table above to determine the range, right? Now, the first thing you have to identify, what are we looking at here, right? So we have 30 students, they're taking a maths test, right? So the marks, right? The lowest mark here is 1 and the highest mark here is 10. So when they ask you for the range, right? So range is actually max minus min. So the maximum mark somebody got was 10. The lowest mark somebody got was 1. So therefore the range has to be 9. Right? You're not going to tell them the range is 1 to 9. You're going to subtract it for them. Right? The next part, they want the modal mark. Right? So the mode is the one that has the highest frequency. So if you look at the frequency here, right? Right, now you have to be careful here, right? So this is the frequency column here, right? So you're looking for the highest frequency. Now when you look at the scores here, you realize the highest frequency is 8, right? So that means that the modal mark is going to be 3, right? Not 8, right? But the modal mark here is going to be 3. That's it, right? The next part, they want the median, right? So when it comes to median, median is your middle, right? Median is your middle. So here's what you need to do. You have a total of 30 students, right? 30 students. Now, you have to ask yourself, is 30 an odd or an even number, right? That's what you need to ask yourself. Is 30 odd or even, right? And you're going to tell yourself, well, no, it's even, right? So there's no exact middle, right? So what we're going to do, we're going to take our data and divide it into 2 equal parts. So you're going to get 15, right? Now, this is where things get a little dicey for some students, right? You want to get the median, right? So there is no exact middle, right? So let's put, this is our first student, this is our 30th student, right? Now you want to get the median, right? There's no exact middle, so let's draw a line in the middle of this data here, and that's where our median is going to be. That's Q2. Now we divided our data into 2 equal parts, right? So therefore from here, from 1 to 15, right? That's the first 15 students. And then what happens here now, we have 16 students. So if you want to get your median, which is Q2, I need to figure out what score did the 15 child get and what score did the 16 child get. Now this is a little problematic for some students, right? Now you have 2 ways you can do this. You can look directly at the cumulative frequency to figure this out, or you can go ahead and add if you want, right? So I need to figure out where is the score of the 15 child, right? Now if you look at the cumulative frequency here, you realize that takes into account, that's a total of 15 students accounted for. So the 15 child actually got a score of 3, right? Because it belongs to this row here. The 15 child is in that row. The 16 child now, right, falls into this category here. So the 15 child actually got a score of 5, right? Got a score of 5. So therefore, the Q2 or the median, right? Let me see if you all see in my screen here. The median is simply going to be 3 plus 5 all over 2, right? So this is your median, which is Q2, and that's going to be 4, right? So the median mark is going to be 4, right? All right, and oh, they have a next piece here. Okay, so this statistics question, honestly guys, this is not difficult at all, right? They want us to calculate the mean. All right, so they want you to calculate mean, right? I need some data from that table. Let's see. Alright, so this is data from the table here, right? And you want to get the mean. So the mean mark is given by this formula here. X bar is equal to sigma xf, right? All over sigma f, right? That's your mean. So what is xf, right? So these would be a variable here, which in this case is marks. This is your frequency. So what you would have had to do is you can actually work it out or just add a next line to your, a next column to your table. So you're taking the marks and multiply by the frequency. So this is going to be 3. This is 2 by 4 is 8. This is 8 3s are 24. 5 3s are 15. This is 7. This is 8 6s are 48. And the last one is going to be 50, right? Now your sigma f here, right, is going to be 30. They told you at the beginning you have 30 students, right? So we know the bottom part of this here is going to be 30. We need to work out what is sigma xf. So you're going to add up everything that we have in that column there. So that's going to be 3 plus 8 plus 24 plus 15 plus 7 plus 48 plus 50, right? And you're going to get 155, right? So the mean is going to be 155 over 30, right? And you're going to get about 5.17. Right, so that's your mean score there, 5.17, right? Right, so that's part 4, right? The next part looks like a probability question, right? So they have a two-way contingency table here. All right, so we have a two-way contingency table, and it shows the gender distribution of students' performance on the maths test. A student is chosen at random, right? So when they tell you a student is chosen at random, it is from the total number of students, right? Find the probability that the student is a female who failed the test, right? So if it's female and she failed the test, it's going to be 13. So that probability is going to be 13 out of 30, right? That's it. You don't need to write the answer as a percentage or a decimal. They gave us numbers here. You can leave it as a fraction, right? So that's part 1. The second part, a male student is chosen at random. So now we've been a little more specific. we selecting a male student, right? Now, if you're selecting a male student, it means that you have a total of 9 male students, right? At random. A male student is selected at random. What is the probability that he passed the test? So in terms of passing, there are 4 male students who pass the test. So this is going to be 4 out of 9. That's it. Nothing too complicated here, right? So that's part 2, and that's it. That's the statistics question, right? Honestly, that was pretty straightforward. Number 6. What do we have here? What is this? All right, so they gave them. All right, so we have the shape here, PMQROS. Okay, is the cross section of a play area in a park. Now PQRS is a rectangle and PMQ is a semicircle. Right? So you have a rectangle, you have a semicircle here. Now what are we trying to do now? O is the midpoint, right? Okay, so let's see what they want. All right, so they want the value of the angle OPQ, right? So where is OPQ? So OPQ is this angle here, right? That's what they want, right? Now, if you look at something here, they've shown that this length here and this length here is the same. So that triangle there is an isosceles triangle. So that angle here, this angle here, and this angle here should have been the same. So if you want to work that angle out, right? So to get this angle here, all we do, we say 180 degrees minus 40, and you're going to divide that by 2, right? So 180 minus 40 is 140 divided by 2, and we're going to get 70 degrees, right? So that's that angle there. So this answer here is simply going to be 70 degrees. 1 mark. Yeah. Calculate the length OR. Where's OR now? So this is O at the bottom here, and you want this length here, right? All right. How are we going to do that? All right, well, what we could do, we can use trigonometry to work this out, right? Now, it's an isosceles triangle here, right? So if that angle is 70, right? If this angle here was 70, this angle here, right? It also means that this angle here is 70 degrees, right? And it also means that this angle here is also 70 degrees, right? Now, you want to calculate the distance OR, that's here, right? This length here is 15, right? So here's what you have. You have, look at this diagram carefully, right? Right, so we have, this is Q, this is O, this is R, right? In terms of length, you know, this is 15, right? This here is 70. Right, and this length here is 14.1, right? Now the thing is, we want OR, right? So OR, we don't have to do anything fancy actually. We can just use Pythagoras' theorem because this angle here is a 90. Yeah, so we can use Pythagoras' theorem, right? So we can say that OR squared plus 14.1 squared, right, is equal to 15 squared, right? So therefore OR squared is equal to 15 squared minus 14.1 squared. So OR is equal to the square root of all of this. Right? I was going to use trigonometry, but we don't need to, right? So this is 15 squared minus 14.1 squared. Find the square root. And this is going to be about 5.1. Right? 5.1 what? Meters? Yeah, 5.1 meters. Right? So that's going to be the answer for this part here. 5.1 meters. And they're giving us 2 marks for that. What else we need to work out? Calculate the area. This one carrying a little more marks here. Right? We want to calculate the area of the shaded portion of the diagram. Right? Now let's go back to the diagram. So the shaded portion of the diagram includes, okay, so this is 5.1, right? So that means that on this side here, this is also 5.1, right? So therefore, you can actually work out the area of the triangle by using a half base by height over 2, because you see this length here, right? This length here is actually going to be 10.2, right? And you're going to take this and add it to this. So the area of the triangle right is equal to a half by a base. So the base is going to be 10.2, right? Multiplied by the height. The height of this triangle is 14.1, right? 14.1. So therefore, I can work out the area of that triangle. So that's 0.5 multiplied by 10.2 multiplied by 14.1, and we're going to get 71.91. Right? Now we're dealing in meters, so that's meters squared, right? Next thing we need to work out this area here. They told us that's a semicircle, right? So the area of the semicircle is simply going to be, so area of semicircle right is going to be the area of a full circle divided by 2. Now they told us to take pi as 22 over 7 multiplied by the radius squared. Now if we're looking at this as part of a circle, the radius is going to be 5.1. So this is going to be 5.1 squared. So that's pi r squared. And you have to divide that by 2. Right? So when you work that out, we're going to get 22 over 7 multiplied by 5.1 squared, right, divided by 2. And we're going to get about 40.87. Right? I didn't round off too early because I know I have to add this to the triangle as well. So they want the area of the shaded region. So that area is simply going to be the area of the semicircle, which we got 40.87. Right? That's the semicircle. Plus the area of the triangle, which is 71.91. Right? So that is 40.87 plus 71. At this stage, you could potentially round off if you need to, but so that's the area here, right? That's the area. Right, now they want perimeter now, right? So the perimeter part is a 3 mark as well. Alright, so this is the diagram here, right? And you want the perimeter of this thing, right? Now this perimeter is not too bad here, right? Now the perimeter of what? Perimeter of the cross section PM, Q, ROS. Now you have to be careful here, right? What perimeter are they talking about? So they're talking about from here, PM, Q, R, O, and S, right? So that perimeter they're talking about is all of this, right? This plus this here, plus this arc here that we have here, right? So the perimeter is equal to, so let's start. This is 14.1. We had that from before. And we also know that those side pieces were 5.1. So this here was a 5.1. This was a 5.1 as well, right? So the perimeter is 14.1, right? So we add in this plus this length, right? Plus 5.1 plus a next 5.1, right? Plus, right, 14.1, right? Plus, we need to add this curved piece here. Now that curved piece there is the circumference of a semicircle, right? So the circumference of a normal circle, a full circle, is 2 pi r. So if you're looking for the circumference of a semicircle, it'll be 2 multiplied by 22 over 7, right? That's 2 pi by your radius, which is 5.1, right? But you have to divide it by 2, right? So we just need to calculate this here. So I'll work out the curve part first. So that's 2 by 22 over 7 multiplied by 5.1 divided by 2, right? Plus 14.1 plus 5.1 plus a next 5.1 plus 14.1, right? And in total, I'm getting about 54.42 or 54.4 meters, right? I don't know if these numbers looking. Right, so that takes care of number 6, right? So honestly, so far the paper is not too bad. All right, so they give us a sequence here, right? This is number 7. All right, so a sequence of figures is made up of regular pentagons using sticks of unit length. The first 3 figures in the sequence are shown below, right? So basically we just add in, right? Add in a pentagon, right? So we added one this way, right? And then we added one this way, right? So you want to complete figure 4, right? So if you want to complete figure 4, right? Then we can go maybe here, right? Go here. Right, and then here, right? Something like this, right? 1, 2, 3, 4, 5, right? So that's your figure 4, right? It's a regular pentagon, right? Mine not looking so regular, but you get the gist, right? You're getting 2 marks for this, right? Next part here now. 6 marks for this table. All right, so study the pattern of numbers, right? And for each row, right? So we have figure number, we have number of sticks, and we have number of dots, right? So the first thing you need to do, right? In this case here, I would tell students work out for figure n first, right? So when you look at this here, when you jump from 5 to 9, you've added 4, right? When you jump from here to here, you've also added 4, right? So it seems like we are adding 4, right? So that means that 4n has to be somewhere in the formula. Now for figure 1, right? When you plug 1 into the formula, you should get 5. So therefore this should be 4n plus 1, right? You could double check with the second one as well. 4 by 2 is 8, 8 and 1 is 9, right? Let's see what's happening with this one here now. When you jump from 5 to 8, you've added 3. When you jump from here to here, you've also added 3. So therefore, we expect 3n to be somewhere in the formula. So you're going to plug figure 1 and see how can we get 5. 3 by 1, right, will give us 3 plus 2, right? So this here will be our formula for figure n, right? And you can use that to figure out anything else in the table. So let's start with the 20. So this here will be 4 by 20 plus 1, right? So 4 by 20 is 80. 80 plus 1, you're going to get 81. For the next one here, this is going to be 3n plus 2. So that's 3 by 20 plus 2. 3 by 20 is 60. So this is going to be 62, right? And then for this one here now, you need to first figure out what is the figure number. So you just need to put 4n plus 1 equal to 169. So 4n is equal to 169 minus 1. So 4n is equal to 168. And therefore n is equal to 168 over 4. Right? So therefore n is equal to 4 4s are 16. And then we have 2. So that's corresponding to your 42nd figure. Right? And the number of dots, since you know n is 42, you'll have to take 3 by 42 plus 2, and that's going to give us 128, right? So this wasn't too bad, right? This wasn't too bad. What else we have to do again here? they said write an equation S, right, in S, D, and N to show the relationship between the number of sticks, S, and the number of dots for figure N. So first thing, let's write down, so the number of sticks in any figure is given by 4n plus 1, right? The number of dots is given by 3n plus 2. All right, now what are they asking me to do here? Write Right, so these are the two formulas that we have for the number of sticks, right, and also number of dots, right? Now let's see what they want us to do here. They want the relationship between the number of sticks and the number of dots. That's what they're looking for. How much marks it is? 2. Right, I'm trying to see if there's a simpler way we can find a relationship. Right, you can come up with any relationship. It's just all right. Let's see. What if I do it like this? Right, or maybe I can do it. Hold on. Right, we have 3n plus 2, right, as the number of dots, right? And if you want to get the number of sticks, right, the number of sticks, this is what we need to get, right, 4n plus 1. How do we get that? So what you can do, as you jump from this to this, we have to add n, right, and then we have to subtract 1, right? So you have to add n because n needs to go from 3n to 4n, and the 2 needs to go to 1. Right, so let's see. If we write it like the number of dots, right, minus, right, or we could say plus n minus 1, right, is equal to the number of sticks, right? That could be a relationship, right? So they said they want an equation for S, D, and N, right? So this is a possible relationship that we could use between D, N, and S, right? Unless you all had something simpler. Right, so I've seen some people say they put something like that. So yeah, you could also, so this is one way you can write it, right? Or you could have written it as S, or you could put D as well. You could put D is equal to, right? D could be equal to S minus N plus 1. However you wanna write it, but that seems to be the relationship there. Right? But I more feel I'll put this as the answer, right? All right, so that is question 7, right? Let's move on to question 8, right? TXE's favorite topic, quadratics. All right, this one looking like a nice one here, right? So they gave them a quadratic function, right? It's a quadratic that has a minimum, right? All right, let's see what we want here now. So from the graph, they want the roots of the function. Now, whenever they ask you for roots, right? Roots is simply asking us, where does the graph cut the x-axis, right? So they're trying to tell us to solve this equation here. F of x is equal to 0. And they want to know, where does that happen? If you look at the graph here, all you're looking for, guys, for this one is where does it cut the x-axis? This is your x-axis here. So it's cutting at -2 and it's cutting at 1. So when they ask you for the roots, all you need to tell them is x is equal to 1, x is equal to -2. That's it. That's all they're looking for, right? Part B, the coordinates of the y-intercept of the function. You go to the graph and you look and you see, where is it cutting the y-axis? This is your y-axis here. It is cutting at this point here, right? At -2. So the coordinates of the y-intercept will be 0, -2. That's it, right? That's all they want. Next part. They want the minimum value of the function, right? The minimum value of the function, right, is simply this lowest point on the graph here, which, now this one here, you all have to read this out accurately. So that's going to be about -2.2, right? So this here, the minimum value is about -2.2. That's it. Don't tell them 2.1, right? They won't give you that correct, right? Because every small line, right? Let me make sure that's correct. Hold on, I'll back up a sec. I might have to retract that statement. Hold on. Okay, yeah, I have to change that. It's not -2.2. Alright, I thought the numbers were incrementing by... Alright, so here's what we need to do. So let's look at this interval here, right? So from here to here, right, that is... Or let's do it from on top here, right? From 10 to 12, that's an interval of 2, and you have a total of 5 blocks in between it, right? You have a total of 5 blocks. What that tells me is that each small line is represented by 0.4, right? Each small line is represented by 0.4. So if I go to read this off here, the actual minimum value is going to be -2.4. That's what the answer is supposed to be, right? -2.4, right? That's the minimum value. The next part, they want the equation of the axis of symmetry. So guys, when it comes to the axis of symmetry, right, remember, your axis of symmetry is simply a vertical line, right, that passes through the minimum point or the maximum point, right? So this question may have given you all a little challenge, right? Right, so just now, I just want to get a vertical line. We're looking for the axis of symmetry. All right, so what you will do, let's come to the graph here, and we're trying to read off where is that minimum point, right? Now again, that looking kind, you're gonna have to estimate here, right? Now my graph is a little warped, right? So it is actually cutting the x-axis at -0.2, -0.4, right? So the answer is going to be negative. Make sure I tell this correct, okay? -0.2, maybe -0.4, right? And one equation, so you have to write it like this. Now you can actually double check your answer. So if I were you in the exam, I could double check my answer. Y is equal to x squared plus x minus 2, right? Now if I compare this with y is equal to ax squared plus bx plus c, right? I can get that a is 1, b is 1, and c is -2, right? So to find the equation of the axis of symmetry, there's a formula. That's minus b on 2a. Now I'm only doing this to double check my answer, right? So minus b is going to be -1 all over, right, 2a, which in this case is going to be 1, right? So this is actually going to be -0.5, right? So let's go back to that graph there. All right, so because the graph for me a little warped, right? So this is actually, so the answer really, guys, is supposed to be -0.5, right? So let's adjust this value here. It should be -0.5, right? So the calculation is telling me that, right? So let's change this answer to -0.5, right? Based on calculation, that's what it should be. And the last part of this question, sorry, not the last part, part B. On the P of axis, draw the line y is equal to 2x plus 4, right? So to draw any straight line, we need 2 points, right? So y is equal to 2x plus 4, right? Now the y-intercept here is already 4, So you know that one point on that line should be 0, 4, right? Now let's see what we have here on the graph, 0, 4. We can probably, let me check something. Does the graph go up to 10? Yeah, it does, right? So let's say, let's plug in a value here. Let's plug in x is equal to 2, and let's see what happens. Y is equal to 2 by 2 plus 4. So that's going to give us 2 2s are 4, and 4 is 8, right? 2 2s are 4, and 4, 8, yeah. So therefore, this point here is 2, 8. So you only need 2 points to draw a line. So we can use 0, 4 and 2, 8. So 0, 4 is here, right? And 2, 8 is up here. So what you need to do now, you need to draw a straight line, right? That is passing through those 2 points, right? Right, so it kind of looking like that, like the graph paper itself kind of warped. If you look at the copy of the graph paper we have here, it's a little warped. So right, so it looking like, right, so that's, so you're drawing the same line. So we did that for 2 marks, right? And they said they want you to use that now to solve this pair of simultaneous equations, right? Now, if you want to solve the pair of simultaneous equations there, all we doing, we just trying to find out where do they intersect. It seems to be cutting here, and it seems to be cutting here. What are those values? So it's cutting at -2, and it's cutting at 3 here. So therefore, the answers will be x is equal to -2, and also x is equal to 3, right? But let's give them the x and the y value. So x is -2, and y is equal to 0. That's one solution, right? Or you could have written it as -2, 0. So that's one solution. The second solution here is going to be 3, 10. Yeah, this point here is 3, 10. So you can also give it as just 3 and 10, right? Or you can say x is equal to 3 and y is equal to 10. That's another solution, right? Right, part C is on speed time graph, velocity time graph, right? Covered this in our crash course. All right, so what do we have here? The following diagram shows a velocity time graph of a car's journey from town R to town Q. The car accelerates for 2 minutes, right? And then travels at a constant maximum speed and then slows to stop, right? So that's standard graph. And the first thing we want to calculate the acceleration of the car, right? So you want the acceleration of the car. Now, the acceleration of the car is simply the gradient of this section of the graph here. See this section here? Right? That is what we want. We want to get the slope of that line, because the slope of a velocity time graph will give me the acceleration. So acceleration, right? Now all you can do, you can simply say it's your change in y over the change in x, right? So the change in y, so let's draw a little right angle triangle here, right? So if I come down here, right? Let's shift this a little bit. Right, so that vertical height there is 30, right? That's 30 divided by the horizontal piece here, right? This horizontal piece here, right? Now this is 60, that's 180, so therefore this here is 120. So you're dividing this by 120, right? So this is going to be 3 over 12, which is a quarter. So this is going to be 0.25 meters per second squared, right? It's acceleration, right? The next thing we want to calculate the total distance between the two towns, all right? Well, that's simple as well. So to get the total distance, what we need to do, we need to work out the area under the graph, right? That's how you work out distance from a velocity time graph. So you have two ways you can do this. You can break it up into two triangles and a rectangle if you want, right? Or you can simply use the formula for the area of a trapezium, right? I'm going to just use a trapezium, right? So it's going to be a half the sum of the parallel sides multiplied by the height, right? So this is going to be a half the base of this thing, right? Now remember, you're going up in 60s here, so you need to figure out what is this value here, right? So that's going to be 780 plus 60, right? So this here is 840, right? So that's the base, right, of this trapezium. So this is going to be 840 plus, we need to know the distance on top here. So this is 120 here, right? And this here is how much? Make sure I don't mix this up. This here is 600, right? So this here is 600, right? And this is 120, right? So you could use those two numbers here to calculate that length. So 600 minus 120, you're going to get 480. So this length here is actually 480, right? So 480, right? And you're multiplying that by the height of the trapezium, which is going to be 30 in this case here. Right, now this is just one way, like I said. If you broke it up into two triangles and a rectangle, you should get the same answer. So that's 480 plus 840 multiplied by 0.5 multiplied by 30, right? And we get in about 19,800, right? And this here is meters, right? I don't know if you all got something close to that. Right, so that takes care of number 8. What is number 9 here now? So number 9 looks like a bearing question. All right, so a ship sails from point A to point B, right, which is 15 kilometers from A on a bearing of 42. The ship then sails to a point C, right, which is 19 kilometers on a bearing of, okay, so based on the information here, they said they want to insert the 42 and the 130. So you see this point here has to be B, right, and this point here has to be C, based on the information that they're telling me here. So you want to, so this distance here is 15 kilometers, right? This here is going to be 42, so this is 042. That's your bearing here, right? That's this bearing, right? Then they also told us that the ship sails to the point C, so this is 19 kilometers, right? And that bearing here, right? So the bearing from B, so this is your north line again, right? Let's label our north lines. And this angle here is going to be 130 degrees. Right? So that's that bearing there. So we want to put in that information, and now we want to calculate the distance between town A and town C. So that's here to here, right? That's what you want to figure out. Now, how do we do that? How many marks they given us for this? Serious? Only 2 marks? All right. So here's what you need to do, right? All right, here's what I would do. So I can actually work out what is this angle here, right? Now that angle here, this angle here is simply going to be 180 minus 42, right? So that's going to be 180 minus 42, and you're going to get 138, right? So this here is, sorry, that's 138, right? So if you know that's 138, we can actually work out what is this angle here, right? So this angle here, right, this angle here is actually 360, right, minus, right, we need to add up, let me put it on the outside, right, in case I need to draw anything on the inside here. So this here is going to be 360 minus 138 plus 130 right, and we're going to get an angle of 92 degrees, right? So let me double check that. 138 plus 92 plus 132. Yep. So that's 92 degrees, right? So this angle here is 92 degrees, right? Now they want you to calculate the distance between town A and town C. So I actually did something like this last night. So basically, you want to get this length. So we're going to use the cosine rule. Right? So in terms of the cosine rule, we're going to say that AC squared is equal to 15 squared plus 19 squared, right? Minus, open brackets, 2 by 15 by 19 by cosine of 92. Right? So therefore AC squared, right? I'm just going to work this whole thing in my calculator, right? So 15 squared plus 19 squared minus, open brackets, 2 by 15 by 19 by cosine 92. Right? Let me double check that. 15 squared plus 19 squared. It's 2 by 15 by 19 by cosine 92, close brackets, equal. Right, so I'm getting about, let's say, 605.89. So therefore AC is equal to the square root of 605.89. So therefore AC is equal to about 24.6. And this is in kilometers, right? So surprisingly, they only give you 2 marks for that, right? 2 marks for that. And the next part, we want to get the bearing. This one is 3 marks, so this one is a little more. Determine the bearing of town A from town C, right? So the bearing of town A from town C. So let's go to town C. Right, so this is town C here, and you want the bearing of E. So you want this whole angle here, right? That's the angle you want. So what we could do, right? We can work out this angle here. Let's call this angle theta, right? You can work out that angle theta. What I can also do, I can work out, in the meantime, I can get this angle up here. We can work out this angle here, right? This angle here, this pink angle here, right? All we need to do, since you know this is 130, you can get a pink angle. That is going to be 180 minus 130, right? So that's going to be 50 degrees, right? I'll need that in a sec. So this angle here has to be 50 degrees, right? So if I want to get this bearing, all I need to do is to figure out what theta is. And in order to figure out theta, what we can do, we can use our sine rule in order to do that. So this length here was 24.6 kilometers, right? And we have the angle opposite, which is 92. And we also have this is 15, and we need to figure out this. So we can use the sine rule, right? So using the sine rule, right? This question looks very similar to one of my sample exam papers. All right, so let's start with 15 over sine theta. Right, is equal to 24.6 over sine 92. Right? So at this stage here, what we could do, we can cross multiply. So this by this is equal to this by this. Right? So we can say that sine theta is equal to 15 by sine 92. Right? All over 24.6. So therefore, sine theta is equal to 0.609. So therefore theta is equal to arc sine 0.609 right, and I'm getting about 37.5, right? Now I'm just gonna round this off to 38, right? I'm just gonna round it off to 38, right? It's really 37.5 I'm getting, but I'm rounding it off to 38, right? So now the bearing that they're looking for, right? So the bearing, so you know this angle here now is, this angle here is 38, right? So we're gonna use the 38, we're gonna use the 50 because this is what you're trying to calculate. You're trying to calculate that angle there, right? So the bearing that they're looking for, right, is going to be equal to 360 minus, are we going to add up the 38 plus the 50? $272, right? So that's the bearing that they're looking for, right? Around 272. Right? This question seems rather long, right? Part B, right? Part B is circle geometry. So we have L, M, and P all lying the circumference of the circle. NP is, what is NP? Right, NP is a tangent, right? OMN is a straight line. PL is a diameter, right? Angle, that is 24. All right, so make sure we have it clear that this here is a tangent, right? The first angle we want to calculate is PON, right? We want to calculate PON. That's this angle here, right? Well, if this here, right? If this here is a radius, right, or a diameter, anyhow you want to look at it, it means that this angle here is a 90-degree angle. So if that angle is 90 and this is 24, we can actually calculate PON. So PON, right, is simply going to be equal to 180, right, minus 90 plus 24, right? So the reason that you're going to give here for your answer is that the angle between a tangent and a radius or a diameter is 90 degrees, right? So this is 90 plus 24, close brackets. So this angle here looks like it is 66 degrees, right? That's it. That's all they want here. All right, 2 marks for that. They want angle PLM. All right, angle PLM. Where is that now? PLM is up here, right? So this is not too bad as well, right? Because you see this line here, this line PM, that's a chord, right? And if this angle here is 66 degrees, right? This angle up here, right, is going to be a half of that, right? So that's going to be a half of 66, and that's going to give us 33 degrees, right? So the angle at the center is twice the angle at the circumference, right? That's basically what we're using there for that one, right? So this angle here is 33 degrees, right? PLM. What else we have here? We want angle PMN. Right, angle PMN, where is that? PM. Right, so we want this guy here, right? Now, how are we doing that now? Well, we're going to use the fact that this here is a radius and this here is also a radius, right? Now, because this angle here is 66 degrees, I can actually work out this angle here because it's an isosceles triangle, right? So this purple angle here, you can work that out. That's simply going to be 180 minus 66 over 2, right? So that's 180 minus 66 divided by 2. So that angle there is 57 degrees, right? That angle is 57 degrees. So if you want to get this red angle here, right, which is PMN, so you want this angle here, that angle there is simply going to be 180 degrees minus 57, right? And that's going to be angle PMN. So 180 minus 57, you're going to get 123, right? So this answer is 123 as well, right? All right, so that takes care of number 9. Let's see what number 10 is, right? Usually this is a trouble question. All right, so they gave them this here, right? Some information, right? We have a parallelogram. OP is equal to R, OL is S. T is a point such that PQ is equal to QT. And they tell us that PL is in the ratio 2 to 1, right? So if this ratio is 2 to 1, let's divide up our lines into 3 equal parts, right? So this line PL is divided into 3 equal parts. This is 1, this is 2, this is 3. Now let's see what they want me to calculate. So the first part, they want us to calculate PL in terms of RS. So that's pretty straightforward. Based on the diagram there, PL, so the vector PL is simply going to be PO right, plus OL, right? That's how we're going to calculate that vector there. Now PO is in the opposite direction to R, so this is going to be minus R plus OL, which is going to be S, right? So it's minus R plus S. That's the answer for the first part. They only get him 1 mark for that because, yeah, that's it, right? And they want OM. Let's go back here now. So this is the next vector they want. They want the vector OM. Where is OM? So OM is this vector here, right? So based on the diagram, right, OM is actually equal to OP, right, plus PM, right? That's the vector OM, right? But the thing is, PM, right, is actually, based on the ratio, right, PM is actually 2 parts or 2/3, right, multiplied by PL, which is the vector we just calculated. Now let's write something here. So OP is equal to R, right, plus 2/3 multiplied by PL, which in this case is minus R plus S, right? So this here is going to be R minus 2/3 R, right, plus 2/3 S, right? Now we could simplify this a little more. So R minus 2/3 will give me 1/3 R. So this is 1/3 R plus 2/3 S, right? So that's what we have here, right? So that's OM. The next thing now, all right, so we want to prove collinearity, right? So we want to prove that OM and T are collinear, right? OM and T, right? So that means that if I were to project this line here, right, it means that those OM and T are collinear, meaning that they are the same straight line. That's what it means, right? So for this one here, right, you have options. You just worked out OM. If I were you, I will work out OT as well, right? You already know the vector OM. Let's work out the vector OT, right? Now this is a parallelogram. So that means this is S and this is also S, because they said that Q, right, PQ and QT, right, they told us this here. They're the same vector. So all I'm going to do, I'm going to work out OT. So OT, based on the diagram, right, is equal to OP plus PT. Right? Now the vector OP in this case is R, right? And the vector PT, according to the diagram here, you have a S here and you have a S here, so it's 2S. right? So that's the vector OT. Now I already know what OM is. OM is equal to 1/3 R plus 2/3 S. Right? Now last night in our little revision class, I showed you all how to treat with this. Now you want to prove collinearity, right? Now you already have OT and you have OM. So what you're trying to do, you're trying to find if there's a relationship between two of them. Since they're kind of telling us to prove it, all you're going to do, you're going to say OT, right? The vector OT has to be equal to K, some constant, multiplied by the vector OM, right? Now OT is R plus 2S, right? And this is K. We don't know what K is. We're going to figure that out in a sec, right? OM is 1/3 R plus 2/3 S, right? Now I'm going to use that information now to figure out what is the value of K, right? So here's what you're going to do. So on the right hand side here, that K has to be multiplied by this and it has to be multiplied by this. So what we can do, we can come up with a simple relationship. Look at this here, that R term, and look at what this R term is going to be. So we can say that 1, or we can say R is equal to K multiplied by 1/3 R, right? So that means that we can say that 1 is equal to K over 3. So therefore K is equal to 3, right? So what that means is that if K is equal to 3, that means that OT is equal to 3 times, right, the vector OM, right? So this is what I've proven here. I've proven that one vector is a scalar multiple of the other. So you're going to say, this is how you're going to answer the question. So you're going to say, since OT, right, is a scalar multiple right, of OM, right, we're going to make a statement and we're going to say they are parallel, right? So they are parallel, right? So this is what CSEC will expect us to see, right? So you get a 1 mark for that. And then we're going to say, since, right, OT and OM, right, have the point, right, O in common, right, we're going to say that O, T, and M are collinear, right? So usually when you have to prove that things are collinear, there are 2 statements that are required. One, you need to say that one is a scalar multiple of the other, therefore they are parallel. And then we need to say that there is a common point. That's where the second mark comes into play, typically, right? Right, so let's do the last piece here now. Right, so we want to find the matrix A by B plus C, right? So the first thing we want to work out, let's work out AB, right? So the product AB is going to be 3, 2, 5, 4, and you're multiplying that by 4, 0, 2, 3, minus 1, and 7. All right, so we're going to use our row by column, right? So let's take this row by this column here, right? So that's going to be 4 3s are 12, 12 and 6 is 18. So the first number here is going to be 18. We're going to take the same row and now you're going to multiply by this. So that's going to be 3 by 0 is 0, 2 by minus 1 is minus 2. So this is minus 2. We're going to take that same row now and we're going to multiply by this column. So 3 by 2 is 6 and 7 by 2 is 14. So that's going to give us 20. And then we need to multiply. We'll switch rows now. We go into this row. So this row multiplied by this column. So that's going to be 5 4s are 20, right? Plus 12. That's going to give us 32. right? Then we're going to take that same row, but you're going to multiply by this column here. So 5 by 0 is 0. So this is going to be minus 4. And then that same row, but you're going to multiply by this. So 5 by 2 is 10, right? So that's 10 plus 28. So that's going to give me 38, right? Hopefully we correct it. And then we need to add that now to C. So this answer that we just got here, we're going to add it to the matrix. So AB plus C is simply going to be 18 minus 2, 20, 32 minus 4, 38, right, plus C, which is 4 minus 1, 2, 7, 3 minus 5, right? So this is, are we adding it? Yeah, we adding, right? 18 plus 4 is 22, minus 2 plus minus 1, this is minus 3, this is 22, this is going to be 39, minus 4 plus 3, this is minus 1, 38 minus 5 is 33, right? So hopefully that's correct there, right? If you see any errors, just let me know, right? Right? Oh, we almost finished here. This next piece, we want to get the inverse of this matrix. So the matrix A here, right, is given by 3, 2, 5, 4. So A is 3, 2, 5, 4, right? You want to get the inverse of the matrix, right? So the first thing we need to do, we need to find the determinant. So the determinant would be 3 by 4 minus 2 by 5, right? So 3 by 4 is 12 minus 2 by 5 is 10. So that's going to give us 2. So the inverse of the matrix is given by 1 over your determinant, which is 1 over 2. And you have to put on the adjoint matrix. So swap these positions. So this is 4, 3. This is minus 2, minus 5. So you can leave your answer like that, or you can write it down as 2 minus 1 minus 5 over 2, 3 over 2. Right? So that's the inverse there. Right? And the last part, or the last part is a freebie, right? They said to write down the 2 by 2 matrix that represents the product A by minus A. So if you take a matrix and you multiply by the inverse, what you're going to get your identity matrix, right? If you take a matrix and you multiply it by the inverse, you're going to get the identity matrix, right? So in this case here, the identity matrix is given by 1, 0, right? 0, 1, right? So that's what they're looking for here. All right. So alright guys, so this was just a quick run through the paper here, right? This is a quick run through, right? I hope it was helpful, right? I hope it was helpful, right? So that's it guys, right? That's it guys, right? Yes, paper 2 is out of 100, right? Yeah. Right? So remember, you all have the paper 1 to prepare for. So focus on the paper 1 now. Can't do anything about the paper 2 anymore, right? So guys, good luck. Right, good luck, right, and we'll see what happens a little later on, right? Take care, people. I have a next class to go to.